Today we shall discuss on orbital analysis. We know that there are different types of orbital. At first we discuss on s orbital. What is the shape of s orbital?
Spherical.
The shape of s orbital is spherical, symmetrical. And s orbital is represented as in two ways. In these two cases, look at that the positive signs and negative signs. These positive and negative signs indicate the phase of a wave or the phase of electron cloud. As we know that electron has dual character, one is particle character, another is wave character. Electron moving like a wave has two phases. One is positive phase, another is negative phase. When we represent the s orbital like as, the positive sign indicate the electron cloud present in positive phase. The negative sign indicate the electron clouds or electron density present in negative phase. Next point, when we move from center to right, we get positive sign. When we move to left, also get positive signs. When we move towards up and also down, we get positive sign. That means we can say that s orbital has center of symmetry. S orbital has the orbital which has center of symmetry is called geared orbital. Is called geared orbital. Now focus on what is center of symmetry. Consider a model. In this model, it is the center of atom or central atom. When we move towards up, we get a white atom. In opposite direction also get a white atom. In another direction get white atom. In this opposite direction we get also white atom. Then we can say that that center or that compound has center of symmetry. That compound has center of symmetry. Take another example. In this model, suppose it is the center of the molecule. When we move towards, we get the black atom and also here black atom. In same direction and opposite direction also same atom. Then we can say that that compound or that molecule has a center of symmetry. Similarly, in s orbital has also center of symmetry. The orbital which has center of symmetry is called geared orbital. Now another point, the s orbital has present in both x-axis, y-axis and z-axis. This is x, y and also in z-axis. That means s orbital has no particular direction. That means s orbital has no particular direction because it has both x, y and z axis, and hence s orbital has non-directional character. S orbital has non-directional character. Suppose, consider an example. If I throw a ball into your body, if I throw a ball into your body, suppose this is a sphere or ball, I throw you into your body. At that time also I throw you a knife into your body. Who can say that which one penetrate into your body? Knife. Because knife has particular direction. Because knife has particular direction, ball has no particular direction. It has both x, y and z axis, but a knife has particular axis. So that the knife can penetrate into your body, the ball cannot penetrate into your body. So we conclude that S orbital has non-directional in character and it has less tendency to penetrate or less tendency for overlapping. Less tendency for overlapping. S orbital has less overlapping tendency because it is non-directional in nature. These are the basic concept of S orbital. At first, the shape of S orbital is spherical, symmetrical. S orbital can be represented in two ways. One has only positive edge, another has only negative edge. S orbital has center of symmetry, so you can say that it is geode orbital. S orbital is non-directional in nature, so it has less penetration power or less overlapping tendency. Now discuss on p orbital. As we know that p subshell has three orbitals. P subshell has three orbitals. One is px, another is py and pz. The shape of p orbital is dumbbell. Shape of p orbital is dumbbell. Px, Py and Pz. Here also plus and minus indicate the phase of a wave where the electrons are present. Please look at this point. When we move, we get positive sign. In opposite direction we get negative. That means p orbital has no center of symmetry. Then the p orbital is called ungeared orbital. The orbital which has no center of symmetry is called ungeared orbital. As we know that p has particular direction in x-axis, in y-axis, in z-axis, we can say that p orbital has directional character. P orbital has directional character. As p orbital has directional character, it has more overlapping tendency. It has more overlapping tendency. This is all about p orbital. In next class, we discuss on the shape of d orbital or about d subshells. It is very important for chemistry.